well today. Excuse me, I see Ashley and Amy here. I hope everyone had a great weekend and you are all set to go ahead and get started with our week 2 of chemistry. So Ashley, I'm hoping you were able to watch the video from last week. Do either of you have any questions about anything we talked about last week? All right, I'm going to send a quick poll just to make sure everyone can hear me. All right, Ashley, it looks like you're the only one here right now. I'm hoping that you can hear me. All right, perfect. Okay, so Ashley, were you able to watch the week 1 video? Oh, I wasn't able to hear you, Ashley. I think you hit the talk button, but I don't think it, I don't think your microphone was on for some reason. So hopefully you were able to see the video. Last week, that's strange. Okay, well, the homework each week is in Moodle, so I will remind you of that website. Okay, that's the website. Your user ID is your user name is your user ID, that 6 or 7 digit number. And everyone has the same password, is Bridgeway9 and the $sign. I did leave last week's homework open still, so you can go ahead and go in and do it at some point this week. That will be fine. Okay, so we are going to go ahead and get started for the day. I'm not sure, maybe we're having some internet issues for some of you. So we're going to go ahead and get started. The first thing I wanted to do was go over the homework a little bit. The homework was a very basic lab report. It was not meant to be a super awesome technical chemistry lab report, but meant for you guys to get the format of writing a lab report down. The lab report that was turned in was done correctly. Great job. I just want to remind you all that this is a class for a half a credit. You do need to come to 60% of the classes. If for some reason you're sick, your internet's down, your whatever the reason may be, just go ahead and send me an email, give me a call, and let me know that you're having trouble so that I can excuse any sort of absence. So that you can still get credit as long as you watch the video and you do the class. Now, the other thing that goes with getting credit for the class is you need to make sure that you're turning in the homework assignments, which I'm sure you all will once you get used to going in and out of Moodle. So this week, we are going to do our first lab. Our first lab is about conductivity, but we are also going to talk a little bit about physical and chemical changes, which is a very important topic in chemistry. To kind of preface this with you guys, I am going to ask for a volunteer each week to let us watch you do whatever the lab is. Now, I'm not going to pick on anybody today since it is the first day. However, keep in mind that I will be asking you each to choose a day and let the rest of the class watch you do the lab. It will be the day of your choice. So just look for that email coming from me. I'm going to send it out later today so that you can go ahead and pick the week that you want to be on camera for the week. With that being said, let's go ahead and look at our first PowerPoint. It's actually the only PowerPoint we'll look at today. The lab is going to take should take about 30 to 40 minutes. I'm going to leave us about in the middle of class just in case things run over a little bit. So up at your PowerPoint screen, you should, which is the top right-hand corner, you should see a PowerPoint that says Physical and Chemical Changes. Just to remind you all, to make that bigger, you can click the arrow that is pointing up and to the right, and then that becomes your entire screen. So here we go, Physical and Chemical Changes. Everything that has mass and volume is called matter. Now last week we talked about the different phases of matter, the difference between a solid, a liquid, and a gas. So all matter, regardless of its state, can undergo physical and chemical changes. These changes can be microscopic, meaning you need a microscope to tell, macroscopic, meaning they're large scale. This is a nice little chart that tells us about some properties of matter, a simple little description, and an example. Today, we are going to talk about electrical conductivity. A description or a definition of that would be the ability to carry electricity. Different elements, different metals, different matter has better ability than other elements or matter to carry electricity. An example of this would be copper. Copper is a good electrical conductor. So we use it in wiring in your houses. Wood is a poor conductor. So you don't have wooden wires running through your house. You have copper wires. Heat conductivity is the ability to transfer energy as heat. Aluminum is a good heat conductor, so it's used to make pots and pans. If you are cooking a grilled cheese on your oven, you don't put the bread right on top of the burner. You put the pot in between. The pot is a conductor of electricity. Density. Density is a mass to volume ratio of a substance. It's a measurement of how tightly packed matter is. Melting point. Melting point is the temperature at which liquid boils. Next week, melting point is the temperature at which a solid changes to become a liquid. Next week, we are going to talk about melting point and supercooling of liquids. So an example of a melting point would be ice melts to a liquid water at the melting point. Each type of matter has its own melting point. Boiling point is the temperature at which a liquid boils. And at that point, it changes state to become gas at a given pressure. Liquid water becomes water vapor at the boiling point of water. Another property is called the index of refraction. The index of refraction is the extent to which a given material bends light passing through it. The index of refraction of water tells you how much light slows and bends as it quickly passes through water. Malleability is the ability to be hammered or beaten into thin sheets. Silver is very malleable, So it's used to make jewelry. It's used to make sheets that can be made into rings, necklaces, whatever it may be. And ductility is the ability to be drawn into a thin wire. Tantalum is a ductile metal, which means it's used to make fine dental tools. It can be stretched very thin. So that's an overview of a lot of different properties. So let's look at what a physical change is. A physical change in matter occurs when a substance changes state but does not change its chemical composition. For example, water freezing into ice. Cutting a piece of wood into smaller pieces. The form or appearance of the matter has changed, but the properties of that substance are still the same, meaning it has the same melting point, it has the same boiling point, it has the same chemical composition. Melting point, boiling point, vapor pressure, color, state of matter, density, electrical conductivity, solubility, absorption to a surface, and hardness. These are all physical properties. Now, both physical and chemical properties can be intensive or extensive. Any guess what that means, Ashley? You can either try your mic again, or you can just go ahead and put it in the text chat. It's also okay not to have a guess if you don't. Just go ahead and write that. Fair enough. I had to put you on the spot. You're the only one in here today. So let's go ahead and take a look. Intensive properties are properties such as density, color, and boiling point. They do not depend on the size of the sample of matter and can be used to identify a substance. So for example, if I have a glass of water that's as big as a cup, or if I have a little teaspoon, no matter what, the color is going to be the same, the boiling point is going to be the same, and the density is going to be the same. The intensive properties, I like to think of it as internal properties. They do not change. They always stay the same. Extensive properties are properties like mass and volume, and they do depend on the quantity of the sample. For example, if I had a big cup full of sugar or a teaspoon of sugar, the mass is different between the two. So that's an extensive property. Physical properties in general are properties that we can determine without changing the identity of the substance we are studying. So without making any permanent changes. The physical properties of sodium metal can be observed or measured. It is a soft, lustrous, silver-colored metal with a relatively low melting point and low density. We did not have to do any physical change to observe those properties, or any chemical change to observe those properties. The hardness, the color, the melting point, and the density are all physical properties. The state of matter and the density of matter are two important physical properties. Now, we talked about states of matter last week, so we're going to fly through these slides here. Okay, density we did not talk about last week. We are going to do some density stuff later on in the course, but I want to introduce you to the concept if you're not familiar with it yet. Density is the mass over the volume. Okay, so we can do various problems, which we're not going to do right now. But volume is how much liquid is there in terms of an amount, a number of millimeters. Now, when we are measuring volume displacement, a solid can displace the matching volume of water when the solid is placed in water. So let's look at these two test tubes. Pretend they are the same. The first test tube has 25 milliliters of water. The second test tube has 33 milliliters of water, plus a solid, it goes up to 33 milliliters, but it has a solid in it. Now, if we know that that solid is a certain mass, we'll say X, but that the amount of water is the same in both these test tubes, we would do the math problem 33 minus 25, so you would have 8 milliliters, or 8 grams, is how much that solid weighs. Okay, a chemical change occurs when a substance changes into something new. A chemical change occurs due to heating or a chemical reaction. You can tell a chemical change has occurred if the density, melting point, or freezing point of the original substance changes. Many common signs of a chemical change can be seen. Changes in color, changes in temperature, the formation of a gas, the emission of light, or the formation of a precipitate. Those are all chemical changes. Okay, and here are some more examples of chemical changes. A reaction with acids, a reaction with bases, a reaction with oxygen, which is called combustion, the ability to act as an oxidizing agent, the ability to act as a reducing agent, a reaction with other elements, and decomposition into simpler substances, or corrosion. Those are all chemical properties. So if you have a nail and it gets rusty, that is a chemical change. Chemical properties describe the way a substance can change or react to form other substances. These properties then must be determined using a process that changes the identity of the substance of interest. One of the chemical properties of alkali metals, like sodium and potassium, is that they will react with water. To determine this, we would have to combine an alkali metal with water and observe what happens. In other words, we have to define chemical properties of a substance by the chemical change it undergoes. So we have bubbles of gas that appear. We have precipitates that can form. Now, a precipitate, you might ask, is kind of a little powdery substance or something that sort of falls out onto the bottom of water. An example of a precipitate, or what a precipitate would look like, is if you took and washed your hands that you were just gardening in. So they had lots of that fine dirt on it, and you washed them over a Tupperware. The dirt that all falls to the bottom, that would be a precipitate. Doesn't really matter what color it is. In a lot of the labs that we do this year, we're going to look at precipitates. Okay, temperature changing, color changing is obvious, or light being emitted. None of the labs we do, we're going to have light be emitted from, but you will see color changes, temperature changes, bubbles of gas, and precipitates form. And all of those things are evidence of a chemical change occurring. All right, and we are going to go ahead and stop there for a second. Now, what we were going to do was make a nice little chart and graph and kind of all participate in it. However, since it's just me and you, Ashley, we're going to make our own chart, but I'm going to participate in it as well. So, I'm going to unlock your whiteboard, and we are going to come up with some examples of chemical and physical changes. Now, I'm not sure if you remember from last year, but in order to write on the whiteboard, you are going to just click on, you should make the whiteboard bigger by touching that arrow that's up and pointing to the right. And then to type, you can find the big block letter A that says text block, and you can go ahead and start writing by then clicking on the box. Oh, I see your word. Perfect. So let's come up with some examples of a chemical change or a chemical property and a physical change or a physical property. So you come up with some and I'll come up with some. All right, looks good. Those are some good chemical and physical changes. Good job brainstorming. Now, I thought I had uploaded a video here. For some reason, I'm not seeing it right now. So I'm going to go grab it again and hope that it comes through. Give me 1 second. All right, let's see if that worked. New. All right, I'm going to go ahead and put something into the text chat for you. Give me 1 second. Okay. So, Ashley, if you go ahead and look back at your PowerPoint screen, I'm going to hopefully share this through there. There we go. And you should be able to watch a video here once I get it started. You're going to have to make that screen larger. This is a little video about physical and chemical properties. Go away.
And then the entire ice melts because of this heat energy being trapped. Boiling point is a property of all liquid substances. All liquid substances, when they gain enough energy, they get the energy and they float away. They float away as a gas. But I haven't changed the properties of that matter in any way. All I've done is I've added energy to it. I've given it more energy. And as it gains that energy, it goes from a liquid to a gas. Pure energy. Malleability. The ability of any substance to bend, but not shatter. Most metals, like this pan, have a high malleability. It's if I take the metal and I hit the hammer, this pan bends, but it doesn't shatter. It doesn't break apart into little pieces. But if I this candy container and I were to hit it with a hammer, it shatters. It breaks apart into little pieces. And because it breaks apart into little pieces, this plastic has a low malleability. Viscosity. Viscosity is a material's resistance to flow. You can experience this in real life easily. Go like this with your hands. You're not trying to fly away, but you can feel the air. You can feel the air. The air is not resisting you hardly at all. It has a very low viscosity. Now, if you were to run into a pool, you'd hit the water and you'd slow down. You'd slow down. Because as you hit the water, you'd encounter the water's viscosity. And water has a higher viscosity than air. Now, we have material that has even higher viscosity than water is oil. Oil has a low viscosity. It does not want to move, so it has a high resistance to flow. And oil, since it has that high resistance to flow, coats the inside of this beaker because it does not want to flow. So when you go with the flow, you're going with viscosity.
Yeah, look at me go. Oh, I'm coming too, dude. Oh, man, this is a little viscous to move through. I know. It's so hard through. This viscosity is horrible. Wait up, guys. Come on. Wait up.
Look! A boiling thing of water! I'm just going to take it off. Conductivity is the ability to transfer energy. Now, my hand is pretty conductive. That glass is even more conductive because it can transfer the energy from the hot plate through the glass into the water. Since conductivity is the ability to transfer heat, to take the water off, I have to use something very non-conductive, like a towel.
Here I have two plates. The one on the left is made of wood. Wood does not conduct heat very well. The one on the right is made of metal. It does conduct heat very well. Let's see what happens when I add two pieces of ice. As you can clearly see, the ice is melting much slower on the non-conductive wood as opposed to the very conductive metal. This concludes the basic physical properties video. Thank you.
Alright, sorry, that was supposed to just go right to you guys, but it worked that way. That was just so you guys could go ahead and see firsthand some of the different properties or physical properties. It's easy enough for me to talk about them. I showed you the little chart, but it's much nicer to be able to see some of them. So, what we are going to do now is we are going to do our first lab of chemistry. We are doing lab number 3 in your lab books. I'm going to go ahead and give you a minute to gather anything you need. The only things you needed for today that were not in your lab kit is table sugar, just normal sugar your mom would cook with, and the distilled water. So, go ahead, get your lab kit, your distilled water, your sugar, and then click yes when you are ready to begin the lab. I will be right back to go grab my water. All right, perfect. So we are going to go ahead and do lab number 3. Part of your assignment last week was to make sure that you read the lab beforehand. Ashley, you said you didn't hear all of the homework directions, so we'll go ahead and go over the goals and a little bit of the safety stuff. Here, I'm hoping you were able to watch all of the safety information that we watched. A reminder for our lab that we are going to make sure we wear safety goggles. That should have come in your kit. You are going to make sure that you keep them on the entire lab. I'm going to go ahead and put mine on under my headset because that's more comfy. Remember, if you wear regular glasses, you need to make sure that you put these on over your glasses so that your eyes are protected along the sides as well. So, let's go ahead and get started. The goals of this lab, well, there are several in the book. They are to gain a better understanding of conductivity in liquids, to observe the conductivity of solutions of salts, strong acids, or strong bases that have a high degree of dissociation, observe the conductivity of solutions of weak acids or bases that have a lower degree of dissociation, observe the conductivity of distilled water that dissociates slightly, observe the conductivity of an organic solution and an organic liquid, as well as complete our first lab. This is a fairly basic lab. So we should, hopefully, be able to do this well. So the background information. Now, Ashley, did you go ahead and get a chance to read this beforehand? Be honest. Fantastic. Then I'm not going to go ahead and read it word for word. I do want you guys to make sure you read the labs before we go ahead and do it. Now, when I am going to do a lab in this class, we are going to, like I said, I do want you guys to be on camera for some of them. This lab, I am going to go ahead and be the one on the camera for it, since it is the first one. Now, what I would do is make sure that I have all of my necessary materials here with me. The well plate, you need the 96 well plate. That's the one with all the little holes, as well as the bottles that are correctly labeled. Now, in your lab kits, there was this little piece of paper that shows you how to make a drop. When you are using the droppers that all of these materials are in, you need to make sure you hold your dropper completely straight up and down as you are dropping. If you hold it tilted to the side, you are not going to get the correct size drop for each of your chemicals, which is very important for our labs to make sure that we get the correct chemicals. I need to grab one more of my potassium hydroxide. Let me find him. It's hiding on me here. And like always, it is the last bottle that I grabbed. Okay, now I have everything lined up on my desk that I am going to need. Do you have everything ready on your desk, Ashley? All right. Perfect. Then let's go ahead and turn to page 4 in our lab kit and go ahead and get started. step number 1, and I'm going to turn on a different camera that's aimed at my desk. So let me switch camera views here. Maybe not. It's not recognizing that camera, so I'm not going to switch camera views. We're going to just angle this down a little so that you can see where I am working, hopefully. Okay. Make sure your glasses are on. Now it says put 2 milliliters using the measuring spoon. Of sucrose into a 150 milliliter beaker. Now the 150 milliliter beaker is your large beaker right there. So I have my table sugar. Now I'm going to put 2 scoopfuls into my beaker. I'm going to make sure that my scoops are level as I put them in. Each measuring spoon is 1 milliliter. In a 150 milliliter beaker, and I'm going to add 60 milliliters of distilled water. So I have my distilled water here in my cup. I'm going to turn my beaker so I can read it. Instead of pouring right into my beaker, I'm going to use a smaller beaker to measure. So this little beaker goes up to 50, so I'm going to measure 50. When I look at my measurements, I'm going to make sure that I am down even with the meniscus. I have 50 milliliters that I will pour in. Now I need another 10 milliliters. If you have any questions or you need me to stop because I'm going too fast, please raise your hand so that it will beep, as I cannot see my screen right now. Okay, so I have my water in there. I'm going to stir it with a graduated pipette. Now my pipettes are in the same container as my ruler. The graduated pipettes are the pipettes with the graduation marks on it, a 0.5 milliliter and 1 milliliter. I'm going to sit until most, if not all, of my sugar is dissolved. Depending on the temperature of your water, yours may be ready, or it may take another minute. Mine appears to be completely dissolved. So I now have about a 1 molar solution of sucrose. I'm going to use a pipette, I can use the one that I just used, to put 5 drops in well A1. Now before you put any drops in your well plate, I want you to look at the rows and the columns. You will see that the rows and the columns are labeled. A through H, 1 through 12. We want 5 drops of this solution in well A1. I'm going to get a nice full pipette. I'm going to go over well A1, holding my pipette straight up. I'm going to put in 5 drops. 5 nice drops. And if I don't have 5 nice drops, I will put my pipette back to get my 5th drop. All right, so that is step number 1. Now step number 2 says put 5 drops of the other materials, KOH, CH3, and the copper nitrate, the glycerin, and distilled water, into the other wells in row A. So you are going to go in that order, making sure that the potassium hydroxide is next. Make sure that you shake your potassium hydroxide and all of your other chemicals well before you put the 5 drops in. So I'm going to angle you back down. I'm going to put 5 drops of potassium hydroxide in well A2. Hold it straight up and down. Okay. Next, I'm going to use 5 drops of acetic acid after I shake it well. If you get any of it on your hands, you are going to stop and you are going to go wash them, rinse them with water. Next, I'm going to put 5 drops of copper nitrate in well A4. I'm going to put 5 drops of glycerin in well A5. It's going to take longer for me to get drops of glycerin. And then I am going to put 5 drops of distilled water in A6. Now, if you are going to use your little thing of distilled water, that's fine. If you are using distilled water from your bigger container, just go ahead and use a pipette for 5 drops. But make sure it's a different pipette than your salt or your sugar water. Once you are done with that, if you could go ahead and just write me in the text chat so that I know you have that part done, that would be great. Awesome. Okay, so now we are going to hook up our battery to the conductivity apparatus. So you're going to take the battery out of the wrapper. You are going to hook it up to the device that looks like this with the little light on the back. You are going to plug it in like you would plug in a smoke detector. Now you want to touch it to something metal just to test it. Okay, you could use a coin. There also is, in that same little baggie, some wire gauze. If you touch it to the wire gauze, the two metal ends, you will see it light up. That's about as bright as it's going to get for the maximum conductivity. Okay, now we are going to test. Step 5, dip both electrodes of the conductivity tester in the solution in well A1. Make sure that the electrodes do not touch each other. So look at Fig 3.1. Observe the brightness of the LED. Bright, dim, or no light. Bright is what it looked like when you touched something metal. No light is no light, and dim is just a little bit. You are going to wash the electrodes in distilled water each time. So I'm going to do my well A1, and I'm going to record my results. Now, I am not going to show you this. I'm not going to share my result with you yet. I want everyone to get their own results. You are going to record whatever you got there in the table on page 25. You're going to rinse those electrodes off and do the same for each well. Go ahead and do that, recording your results. Make sure you're touching the liquid. Okay, now once you have gone ahead and completed your data table, we are going to compare our results. So, I'm going to go ahead and make a table on our whiteboard. Okay, so you can start putting your results in. On the whiteboard. Okay, so if you go ahead and compare our results, and I'm going to put an A over yours and a C over mine, you can see that we had very similar results for everything except, for everything. Okay, so we got the same results for everything. Except for the distilled water. I knew there was one. Except for distilled water, down here, we had the same results for everything. Which means that we probably both did a pretty good job following the procedure. And maybe one of our distilled waters got contaminated and wasn't rinsed, the electrodes weren't rinsed well enough, or a variety of other reasons that could have caused some experimental error on our part. But basically, we got the same results. Now, one of the columns on the chart is asking us for the conductivity. So let's see, we put dim, bright, or none. If there was no conductivity, meaning our light did not show up at all, that means the solution is not a conductor. If it was bright, that means the solution is a very good conductor. And if it was dim, that means it is an okay or good conductor. So that would be the key that would go along with our chart. Now the other column in the table asks you the type of liquid. Was it a salt solution? Was it a weak acid? What was that? So I'm going to go ahead and I'm going to give you that. So here we have our water solution, our sucrose water, is an organic water solution. The potassium hydroxide is a strong base, and we're going to talk about acids and bases later in the course. Our acetic acid solution is a weak acid. Our copper nitrate is a salt solution. Our glycerin, is an organic liquid. And our distilled water is an inorganic liquid. So go ahead and copy those down into your data table for me. And then you don't need to clean your lab up right now during class, but what I would like you to do is to go ahead and take your well plate and go fill it with water so that it can start to soak. Because if you don't clean these off quickly, they can get kind of gross in them. So I'm going to go soak mine, come back, go ahead and put yours in the water. Just leave it in the water for a minute.